Welcome back everyone. Today we will start chapter 12, Heron's formula. Children, you might have studied in your previous classes about the figures of different shapes such as rectangle, square, triangle and quadrilateral. And you have also calculated the perimeter and area of the sum of these figures. For example, you can find the area and perimeter of the floor of your classroom, isn't it so? For example, if your classroom is rectangular with length 10 meter and width 8 meter, then what will be its perimeter and area? So let us recall. Here you can see length is 10 meter and breadth is 8 meter. So let us recall what is the perimeter of rectangle. Its formula is 2 into L plus B. So after putting the values of length and breadth, we'll get perimeter as 36 meter and area of rectangle is L into B, length into breadth. So area will become 10 into 8, 80 meter square. Here you can see the perimeter unit is meter and area unit is meter square. So perimeter will always be represented with meter, centimeter. Units of measurement for perimeter is meter, centimeter or kilometer, and unit of measurement for area is meter square, centimeter square or kilometer square. See, unit of measurement for length and breadth is taken as meter, centimeter or kilometer, and unit of measurement for area of any plane figure is taken as meter square or centimeter square, kilometer square, etc. Now this was about a area and perimeter of rectangular figures. Now what will happen if we have a triangle? Let us take a case of right angle triangle. In right angle triangle, this is hypotenuse, this is base and this is perpendicular, and we know area of triangle is half into base into height, as you have done this in your previous classes. So here you can see base is 12 centimeter and height is 5 centimeter. So when we'll put the values in the formula, we get area as 30 centimeter square. So we can easily find out area of right angle triangle. Now what is the case when what is the area when triangle is equilateral? So let us take an example of a triangle PQR whose all sides are equal. We know that an equilateral triangle has all sides equal. So let each side be 10 centimeter. Now we want to find its area. So again we have to use this formula, half into base into height. But you can see we do not have this height. So first of all, draw this altitude from P to M. So this altitude will bisect the opposite side, corresponding side, into two equal parts. So you can see QM will be 5 centimeter and MR will also be 5 centimeter. So PQM, you can see, is a right angle triangle, and using Pythagoras we can easily find out this perpendicular. So using Pythagoras, hypotenuse square is equal to perpendicular square plus base square. So PQ square is equal to PM square plus QM square. As you know, PQ is 10, so 10 square is equal to PM is unknown, it will remain PM square plus QM is 5, so it becomes 5 square. So after solving, we get PM square as 75, or PM is equal to root 75. Now make the factors of 75, so we'll get PM as 5 root 3 centimeter. So this was PM, so we get the height of this triangle. Now we have base 10 centimeter and height 5 root 3. So put the values in this formula, base and height. So 25 root 3 centimeter square is the area of this equilateral triangle. Now we have discussed about right angle triangle, equilateral triangle. Now let us take a case of isosceles triangle. Isosceles triangle is that triangle whose any two sides are equal. So take an example of triangle ABC, where AB is 5 centimeter and AC is also 5 centimeter and BC is 8 centimeter. Again we have to find its area. So we need half into base into height. Again from A, draw one perpendicular which bisect the corresponding side into two equal parts. In equilateral triangle and in isosceles triangle, this altitude always bisect the corresponding side on which it falls. So this side will be BD is 4 centimeter and DC is also 4 centimeter. So again follow the same procedure. In triangle ABD, this is hypotenuse, AB is hypotenuse, AD is perpendicular and BD is base. So using Pythagoras, again AB square is equal to AD square plus BD square. After putting the values, we will get AD as 3 centimeter. So we get the height as 3 centimeter. Now put the value of base and height in this formula. We will get the area of triangle. So this is how we can solve area of right angle triangle, area of equilateral triangle, and area of isosceles triangle. Now children, what will happen? Now what will be the area of this triangle whose all sides are unequal? Let the sides be A, B, C, and all sides are unequal, and we know that type of triangle is called scalene triangle. Now what will be its area? For that Heron, a famous mathematician of Egypt, has derived this formula, Heron's formula, and it is called after his name, Heron. He was born in 10 AD and he worked in applied mathematics. Heron has derived the famous formula for the area of triangle in terms of its three sides. So what is that formula? See, Heron's formula is area of triangle is equal to square root or under root s minus a, s minus b, and s minus c, product of all four. And what is s here? As you know, perimeter of this triangle is a plus b plus c. So s is called semi-perimeter, that is a plus b plus c by 2. So this is the formula for area of triangle, which is given by a famous Egyptian mathematician, Heron, and it is named after, this formula is named after his name only. So let us take an example how to find area of triangle using Heron's formula. Let the three sides of triangle are 40 meter, 24 meter, and 32 meter. So let first side be A, then B, and then C. And we have to, you can see we use S here, and S is semi-perimeter. So first of all we will find S, A plus B plus C by 2. So after putting the values of A, B, and C, we will get S as 48 meter. Now using Heron formula, area of triangle is under root s minus a, s minus b, s minus c. So put the values of s, a, b, and c. Then after solving, 48 minus 40 is 8, 48 minus 24 is 24, and 48 minus 32 is 16. So make the factors. After making factors, you can see this 4 is written as 2 into 2. So you can see all have pairs, all these numbers have pairs. So area of triangle, after taking out square root, we'll get 8 into 6 into 4 into 2. So area of triangle is 384 meters square. I hope this is clear to everyone how to apply this formula. This is called application of Heron's formula, how to apply this formula in different sums. Now children, let us start exercise 12.1, question number 1. Now what is question 1? See, a traffic signal board indicating school ahead is an equilateral triangle with side A. Find the area of signal board using Heron's formula. If its perimeter is 180 centimeter, what will be the area of signal board? Now you can see we are given one signal board in triangular shape whose all sides are equal. As it is given, it is an equilateral triangle, so all sides will be A, and we have to find the area of this signal board using Heron's formula. Signal board means area of triangle using Heron's formula. So again, first of all we have to find S. S is semi-perimeter, so sum of all sides divided by 2, we get 3a by 2. So using Heron's formula, area of triangle, write the formula of area of triangle using Heron formula, then put the value of S, A, B, and C in this formula. So you can see here we can take denominator as 1. So after taking LCM, we get 3a by 2 into a by 2 into a by 2 into a by 2. So separate this 3 from a by 2. You can see we get pairs of a by 2. So take out the square root of this area. You will get a by 2 into a by 2 into root 3. So this is root 3 a square by 4. As you can see, this is the area of triangle. That is why this is also called the derivation of area of equilateral triangle. We know area of equilateral triangle is root 3 by 4 a square. This is how it has come, how it has derived. So now it is also given that perimeter is 180 centimeter. We know perimeter of equilateral triangle is 3 into side, 3 into a is equal to 180. So a is 60 centimeter. Now put this value of A in area. Here, area of triangle we have already found, root 3 by 4 into 60 into 60. So you will get area of triangle as 900 root 3 centimeter square. So this is question number 1. Now come to question number 2. This is question 2. The triangular side walls of a flyover have been used for advertisements. The sides of the walls are, so you can see this is a flyover and here it is the side wall. And the side wall is in the shape of triangle whose sides are 122 meter, 120 meter and 22 meters. The advertisement yield an earning of 5,000 rupees per meter square per year. And a company hired one of its wall for 3 months. How much rent did it pay? So we have to find how much rent company has to pay if that company hired this wall for 3 months, right? So see, first of all, you can see the wall is in the shape of triangle and its sides are given 122 meter, 22 meter and 120 meter. So this is A, B and C. So first find out semi-perimeter, 132 meters. Then using Heron formula, write the formula and put the values of S, A, B, C, and after solving we'll get this. Make pairs. 132 will be written as, after taking prime factors, we'll take 132 will be written as 11 into 12, 10 into 12, and 110 is written as 11 into 10. So you can see we have pairs of 10, 11 and 12. So finding out square root, we'll get area of triangle as 1320 meter square. Now it is given that the rent for 1 meter square for 1 year, if company hires this wall for 1 year for area 1 meter square, it has to pay 5,000 rupees. So but the company hired it for 3 months. So first of all we'll find for 1 month, unitary method, 5,000 by 12, then 3, 5,000 by 12 into 3. Now area is not 1 meter square, area of wall has come 1320 meter square. So what will be the rent? 5,000 upon 12 into 3 into 1320. So after solving we get the rent as 16,50,000 rupees. So therefore a company will pay 16,50,000 rent for hiring it. So I hope this question is clear to all of you. Now come to question number 3. There is a slide in a park. One of its side walls has been painted in some color with the message, keep the park green and clean. If the sides of the walls are 15 meter, 11 meter and 6 meter, find the area painted in color. Now you can see this is a slide in the form of triangle and its sides are given 11 meter, 15 meter and 6 meter. We have to find how much area is to be painted with color. Now it means we need area of triangle. So see, this is a slide and it is in triangular shape, 11 meter, 6 meter and 15 meter. So A, B, C is 11, 6 and 15. First of all find S and using your own formula, write down the formula, put the values of S, A, B and C, and after solving we get 16 into 5 into 10 into 1. Make the factors of 16, 4 into 4 into 5. Factors of 10 are 5 into 2. So taking pairs, you can see we have pairs of 4 and 5. So taking out square root, we get 4 into 5 into root 2. So area is 20 root 2 meter square. So therefore area painted in color is 20 root 2 meter square. So this completes your question number 3. I hope this much is clear to all of you. So we'll continue with question number 4, 5 and 6 in my next module. Thank you so much.